Hello everyone, my name is Alain Patrick, a student at Institut Polytechnique Unilasalle, Amiens. And today with my classmates Mbeleg Alain, we will explain you a project that we made for a few weeks. It's a Labyrinthe project. The title is The Journey of an Autonomous Robot. Okay, like I was saying, my name is Alain Patrick, and for a second time, good morning.
Okay. Hello guys, my name is Belek Alain Michel. Today we are very excited to present our project. For the past few weeks, we have been working on building and programming this an autonomous robot designed to solve a maze.
Now, when you look at the maze, the challenge seems simple for a human, but the project concerns the robot, not humans. So you can see the whole map, you can find the path. But for a robot, the challenge is very, very difficult.
Okay. Things about it. The robot has no map, it has no GPS, it is blind to the future. It only knows what is directly around it. It must make all of its decisions in real time using only the information for its sensor.
Hmm. So our main goal was not just to build a robot. Our goal was to give this robot something like a brain,
Yeah.
a set of rules in addition that will allow it to be placed in any unknown maze, just an specific one, and completely on its own navigates all the turns and all the dead ends until it finds the exit. Is the second part of our video. In this second part, we will explain you the logic which is on the head of our robot. This logic is the right hand rule. Okay. To solve our problem, we need a simple strategy. We choose a classic and very effective algorithm, the wall follower algorithm. You might know it as the right hand rule. That is his other name.
The concept is very easy to understand. Imagine you are in a dark maze. You place your eyes and on the wall and you start walking. The one rule is you never take your hand off that wall.
If you follow this one simple rule, you will follow the wall. Actually, when you get to a corner, your hand will guide you to turn right. When you get to a dead end, your hand will guide you around and back out. Eventually, you are guaranteed to find the exit in all cases, as long as the exit and the entrance are on the same uh, single outer wall. The different characteristics of our robot, we have the brain, it's like the head, nano Arduino, a typical model. The muscles, two continuous rotation servos, the legs eventually, and three senses, the VL6180X model, like the TOF, the time of flight, laser sensors, They are the eyes and the hands, eventually.
So, to make this strategy work, our robot needed a body. We built it with three key parts. First, the brain. We use an Arduino. This is the microcontroller. It is like the robot's head. It runs all our code and makes all the decisions.
Second, the muscles or the legs. How does it move? That is the real question. We use two continuous rotation servos. These are special motors that act our wheels. They are simple to control. We just tell the brain to make the left wheel turn forward and the right wheel turn backwards, and the robot turns together.
And that's the most important part, the senses. How does the robot feel the world? How does it follow the eyes and hold? For this, we use three high precision laser sensors. There's a time of flying sensors. They are very, very fast and very accurate.
Okay, for each sensor, we give a specific job. What is it? And who are they? The right sensor is our hand. Its only job is to constantly measure the distance to the right wall. It tells the brain the wall is 70 millimeter away, 75 millimeter away, or 60 millimeter away. The center sensor is our eyes. Its job is safety. It looks straight ahead and should stop. There is a wall in front of us. Then the last one, the left sensor. For this project, we don't use it for the main logic. Yes. But we add it for the future. It could help the robot make smarter choices like choosing between left or right turn. But for now, our logic only needs the right and center sensors. In this part, we will explain the brain. In other terms, our code logic. So, we have the strategy and we have the hardware. Now, let's look at the brain itself. This is our loop function. This code runs hundreds of times of every second.
The most important things to understand is that our brain is priority system. The robot cannot do two things at once. It must check a list of roles one by one, from most important to less important.
Priority number one. Am I going to crash? This is always the first question before anything else. The robot checks the center sensor. If an obstacle is closer than our seuil obstacle frontal, which is 18 millimeter, the robot ignores everything else. It doesn't care about the right wall. It stops and makes a hard 19-degree left turn to safety.
Priority number two. Where is my right hand? Okay, so there is no wall in front. The new question is about the right wall. If the wall is further than our target, distance cible plus seuil correction, it means our hand is not touching anything. This could be a right turn or a big open room. The robot must curve to the right to find that hole again.
Priority number 3. Am I too close? Okay. No wall in front. That's good. The right wall is not lost, but is it too close? If it's closer than distance cible mur moins seuil correction, it means we are about to scrap the wall. So the robot must curve slightly to the left just to move away from the wall.
Priority number 4, Goldilocks zone. So what happens if none of the roles are true? It is not trashing. The right role is not lost and the right role is not too close. What does they mean? What that means? Excuse.
It means everything is perfect. Don't worry. The robot is in the sweet spot, is in the Goldilocks zone, just right. And the only command is continue straight, full speed ahead. Okay. In this part, you will explain the journey of failure and calibration.
This logic sounds very simple and in theory it is perfect, but in practice it did not work at all. This is where the real project began. This is the story of calibration.
Exactly. We want to be honest and show you the journey. Our robot was in the beginning very stupid and very clumsy.
Our very first problem was just making the robot move correctly. Before we even tried the maze, we had to celebrate the motors of the floor. We had to find the magic number in our code.
Magic number is excuse me. Magic number are considered like the declaration of numbers like 1, 2, 3 in the code instead of variable like part 1 equal to or another. For example, what does go straight mean? In our code, partie 5 mouvement.cpp avancé, the function called avancé use servo.j.write 118 and servo.d.write 0. We have to find these exact numbers. Those numbers are called magic numbers and not good, and they are not good for a code. And what is the 19-degree turn? We had to find the durée virage 90 degrés. This is a video of our first calibration test on the floor.
As you can see, it is not perfect. Maybe it is not turning exactly 90 degree, or maybe it is curving when it should go straight. We spend a lot of time just adjusting these numbers, durée virage 90 degrés, and the motor speed until the movement feels reliable.
Once we told the models were calibrated, we put the robot in the real maze and it fell again. But in new, more interesting ways, this is the video where it doesn't work.
So, what is happening here? It is getting straight, or it is zigzagging, or it is confused. Why? We discovered the problem has not the motor, it was the parameters for the sensor partie 2 paramètres.cpp.
Now we had two big problems. First, the drone robot. It will zigzag widely, like tug, 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 tug. This was because our seuil correction, this variable, was too small, like 10 or 9. The robot was panicking over a 1 millimeter error. This is very small. We had to widen the Goldilocks zone to maybe 15 millimeter to tell it to relax and just go straight.
Yeah. Second, the hesitant robot. It would stop at corners confused. This was a logic conflict. The front sensor, say of start frontal, was too sensitive and say a ghost, a wall for away, for example. It is wanted to turn left in priority 1, but the right sensor wanted to turn right for the priority 2. The robot was stuck.
The solution was to lower the front sensor's sensitivity to 18 millimeter. So, the failures in this video were all solved by changing the parameters in our code, not the motors. My favorite part, the success. In other terms, just the final demonstration. So, after calibrating the motors on the floor and then calibrating the sensors in the maze, all this failure, all this debugging, we finally had the robot that understood its job.
We present to you our final successful run.
Here you see it approaching the corner. The right sensor detects the wall. It's gone. So rule 2 makes it curve right perfectly.
Now it is approaching a dead hand. The center sensor will fail. It is top perform is it's calibrated 415 milliseconds left turn and continues putting its hand back on the new wall.
And after navigating all the turns, it finds the exit. Success. Okay, the video was too long, but we are in the final part of our project or of our video, the conclusion. Not just the conclusion, but the conclusions and what we learned at the end of this project. 3 points. Success is built on failure. Calibration is 19% of the work. Future ideas may be the PID controller using the left sensor.
This project taught us that in robotics, a perfect algorithm in theory is only 10% of the solution. The other 90% is calibration, testing, and learning from
28,
failure.
The drunk robot and the hesitant robot were not failures. They were lessons. They forced us to understand our own code and the physics of the real world. The real world is messy.
For the future, we could make it events matter. We could use a PIG controller, which is a more advanced algorithm for perfectly smooth curves instead of zigzag.
We could also use the left sensor. If the robot sees walls on both sides, it could measure the width of the corridor or make smarter decisions. But for today, we are proud to have built a robot that can face an unknown challenge and find its way out.
Thank you for very much. Thank you very much for your attention.
We could be happy to answer any questions in the section comment.
Yeah,
Like and subscribe.
yeah.